Good morning, students. Welcome to class on Tuesday, second day back from spring break. I'm sure you guys are excited and bright and early, 8:15 Tuesday morning. Quiz on Friday. I know that's music to your ears, so quiz on Friday. Make sure you're ready for that. On Thursday, I will give specific details as to what will be on that quiz specifically. You do owe me homework from yesterday, so please turn that homework in now at this time. I did not check my YouTube viewings. I hope that some of you used the homework video. If you did not and you still did well, that's fine, but it's important you do your homework every day. Please do that. Please do that. I know I'm probably nagging you, but it's very important that you do that. I also need to hear from you guys if you're going on the national trip, the nationals competition trip next week, I believe it is. So please email me or call me. I need to know. And then there was one other thing I wanted to say, and I'm drawing a blank. What was I going to? Today's going to be a very long video with no homework tonight. Excuse me. I know that's always so attractive to hear me cough into the microphone. Tomorrow there'll be no notes, but tomorrow there will be homework. So do understand you're going to take a lot of notes today. I need you to really focus and really pay attention, but there will not be homework tonight. Very quickly, I just want to pause and review. So go ahead and get your notebooks out. And I do have some chances today for you to earn some bonus points. And so understand that'll help you with your quiz. And then also I'm going to give you some more chances for bonus points tomorrow and hopefully Thursday also. Go ahead and get your notebook out now while I'm kind of rambling on, please. I want to review very quickly, so if you'll look at the screen while you're getting your notebooks out and your books. Don't forget what we looked at yesterday, please. That's a really poor pyramid, isn't it? Wow. That would definitely not make the Egyptians proud. But anyways, here's just some examples of a solid. We talked about a solid as a three-dimensional figure. Here's a cylinder, here's a rectangular prism, here's a pyramid, and these are all solids, okay? Three-dimensional figures. We talked yesterday about a polyhedron, plural is polyhedra, and a polyhedron is a solid that is formed by polygons, okay? And so this would not be a polyhedron here because notice we have a circular top, and that circular top is not a polygon. This cone would not be a polyhedron because it has a circular face right here, or a circular base, and that is not a polygon. This is a polyhedron. Look at all the faces. I've got rectangles all over the place. This is a polyhedron here. Look, I have triangles for the sides. I've got a rectangle for the base. I definitely have a polyhedron here. And then lastly, yesterday we talked about prisms, and a prism has to be a polyhedron. So right away you know that a cylinder cannot be a prism. A cone cannot be a prism. A prism is a polyhedron with two faces that are congruent and parallel. So, excuse me for yawning, two congruent and two parallel faces, okay? In other words, two faces that are both congruent and parallel, okay? And that's a prism. And so just a quick little review there. Let's get into the heart of the notes. Now, I'm going to be teaching today on a pretty tough topic. I feel like this whole chapter is difficult, so please give me everything you got right now. Really pay attention and take some really good notes. And you're going to have to sit for a while, but there will not be any homework tonight. Please copy this into your notes. We're going to start getting into now surface area of prisms and cylinders, okay? Surface area of prisms and cylinders. Lesson 9.2. Today is the 2nd, April 2nd. Hopefully you survived yesterday without too many April Fool's jokes. I would like you to turn to page 483. Would you do that quickly, please? Turn to page, write it right here for you. Turn to page 483. Quickly do that. I'll pause while you're doing that. We're going to look at the top, okay? We're going to look at the top. Now what we're going to be doing today, I want to take a second and kind of explain to you what surface area is, and then we're going to start solving some problems and finding surface area of prisms and cylinders. So please turn to page 483. Hopefully you've done that by now, and if you're at page 483, if you'll look at the top, you should see this right here. look at the screen, you should see this prism right here. Okay? Now what surface area is, let me get out my eraser here. What surface area is like taking this cardboard box right here, and it's kind of, get this thing to work here. There we go. It's kind of just ripping it open and laying it flat. In fact, that's exactly what you're doing. So if you had a knife and you could cut the edge right here, and then here, and then here, and then down the sides on the front and the back there, and then kind of lay it flat, it would end up looking like this right here. And all of that's in your book, of course, okay? And so when I ask you to find the surface area, really you're just finding the area of this flat surface. We call that a net, by the way, in mathematics, N-E-T. Now, I'm not a big fan of using nets to help students see surface area. I would rather just have you look at each side, find the area of that side, then add up all of the sides. And that's how we're going to do it. But for right now, what I wanted to point out to you is surface area is basically taking an object, a solid, and ripping it and laying it flat and find the area of that object, okay? So with that in mind, here's how we're going to attack surface area, okay? Please watch this carefully. Here's what we're going to do. By the way, in your notes, here's what I would like you to do. Because some of these diagrams are pretty tough, I would like you to go ahead and put in your notes page 483. If you would do that, please write that down. So that way you don't have to write the picture in your notes, okay? And that way we're not testing your art skills. So page 483, example number 1, and you'll see it there in your book, okay? Now, first of all, I'm going to take my white out here, and I'm going to get rid of this part of the problem here. I'm going to be honest with you, I am just not a big fan of using a net to find the surface area. Now, if it helps you, please feel free to do it. That's just not how I teach it, okay? I think it's a lot easier to simply look at this object right here and use common sense and say to yourself, okay, I obviously have a top side. I mean, it's a box. Here's my top. And I have a bottom. That's pretty obvious, is it not? And by the way, what is that top? You might want to write all this down. The top is a rectangle. And what is the bottom of this solid or this prism? Well, the bottom is a rectangle. Okay? I'm going to kind of shade that for you. There's the top right there. Everybody see that? And there's the bottom right there. There's the base. So there's the top and bottom, okay? Now, I also have a right side. Everybody see that okay? And a left side. And both of those, I'm going to use ditto marks. Both of those are also rectangles. Okay? I'm going to shade those for you real quick. Here's the right side. Everybody see the right side okay? I'm going to highlight the edges in red. There's the right side right there, okay? And then here's the left side right here. I'm going to kind of highlight that in red for you. And then try to shade that in, all right? So there's the left side right there. So we have a right side and a left side. And then we have top, bottom, left, right, and then obviously we have a front and we have a back, a front and a back, okay? Now the front, take some really good notes here. The front, of course, I'm going to highlight it in red for you. I don't think I'll take time to keep shading these in for you, but there's the front right there. And then using blue, I'm going to highlight the back, or not highlight, but outline the back for you. There's the back right there. There's the front and the back, okay? And those are also rectangles. So here's what I'm going to do. Do you not see what I want to do here, students? It's really pretty simple. I'm just very simply, I'm going to find the area of each of these faces, and then once I find the area, I will add them up. For example, you ready? Let's look at the top and the bottom. The top and the bottom is a what? It's a rectangle, okay? And it looks like, here's the bottom, I'm going to highlight it for you, or outline it. Here's the bottom. It looks like it's a 3 by 5. So 3 times 5, is that how you find the area of a rectangle? 3 times 5? length times width. So the area of the top and the bottom would be the same. They would both be 15. See how easy that is? 15. Pretty simple. All right, top and the bottom. Now let's go to the right and the left. Let's highlight the right side. It looks like to me the right side has a length of 8 and a width of 5, 8 by 5. So in order to find the area of the right and left sides, it would be 8 times 5, which is 40. And of course the left side is also 8 by 5, so it would be 40. So there. I found the area now of 4 faces. And now I've got the front and the back. So I'm going to highlight the front for you real quick. Now this one might be a little challenging, so pay attention here, okay? Because here's the problem. I can see I've got a 3 right here for this, but I don't have any number for this height right here. Well, think about it, students. Wouldn't it be the same as this right back here? Sure it would be. So if this height right here is 8, then this would also be an 8. So this rectangle right here in the front, that's a 3 by 8. So 3 times 8 would give me 24. So if the front is 24, the back is also 24. Well, let's add all these up quickly. You should get 8, carry your 1, 3, 7, 11, 13, 15. Now we did find surface area, and notice everything was in inches, inches, inches. So my final answer would be 158 square inches. Okay, there you go. You just found the surface area of a prism. It's that easy. You simply, excuse me for a second, please. Sorry about that. You simply find the area of each face and then add them up. All right. Now let's take a look at another problem. And I believe this one is, you know what? I don't think you have this one in your notes. Yes, you do. Please turn over in your book. Or you can look at the screen. It's good enough, I guess. But please write this page number in your notes so that you know where this problem came from. So page 484, example number 2. Example number 2. This one's going to be a little more difficult, so please pay attention, all right? Page 484, example number 2. Now, this is going to be interesting because we have 5 sides on this one, so be careful here, okay? Let's start with the bottom, okay? Let's put the bottom face. I'm going to outline it for you. Okay, here it is. See if you can follow along. Here's the bottom. There we go. There we go. There we go. And yes, one more time. There we go. Excuse me. So we have a rectangle. A rectangle. Now what I wanted to show you is we don't have a top. Look at the last problem that we just did. We had a top and a bottom that were the same. We do not have this here, okay? This is not this side, this bottom side right here does not have a top that goes with it, okay? So there's the bottom side, it's a rectangle. Well, okay, I'm not seeing a top. Let's see if we can't go ahead and, let's see. Let's look at the front. Is there a front side, a front, and a back? Let's see if there is real quick. Let's get my red pen here. And here's the front. And it looks like to me the front is going to be the same as the back right back here. They're identical. So there's the front. And there's the back. So what do we have? We have a triangle. Okay? A triangle. Put ditto marks. Okay, so there's the front and the back. Well, there's a total of 5 faces in case you haven't figured that out yet. There's a bottom side, then a front and back, then a left and a right. Now, look at the last problem. The left and the right were the same. See the left and the right? Here's the right side right here. Here's the left side over here. They were identical. That is not going to be the case with this problem, so be careful, okay? Let's take a look at the right side first of all, okay? Here's the right side. I'm going to highlight it for you right here. There we go. And then come down and then over. We're going to call that a right side. It's kind of slanted. We're going to call it the right side. And that is a rectangle, okay? And now, very quickly, we're going to highlight the left side. If I'm going too fast, you can always pause the video. Here's the left side over here. it also looks like a rectangle to me. Okay, so there's my left side. And that's also going to be a rectangle. All right. Now, okay, let's find the area of the bottom side. Let's start at the top here, right up here, right here, and the first thing I see is bottom, so let's go ahead and let's highlight the bottom side here. Looks like it's a rectangle. There it is. There's the bottom side right there. And it looks like it's a 4 by 2. So 4 times 2, the area of the bottom would be 8. 8. All right. All right, let's continue on. And deleted some of my work here. Let me fix that. There we go. Now let's take a look at the front. Here's the front right here. There we go. And in this situation, notice the front will be the same as the back. So let's find the area of both of these real quick, okay? So the front, ooh, it's a triangle. How do you write this down? How do you find the area of a triangle? 1/2 base times height. Do you remember that? So if I take 1/2 times base times height, first of all, the base of this triangle is 4. The height of it is 3. So I'm going to have base times height is 4 times 3. That's 12. 1/2 times 12. And 1/2 times 12 is 6. So the area of this triangle, and don't let me lose you here, look, in order to find the area of a triangle, and that's what this front is right here, it's a triangle, the formula for the area of a triangle is 1/2 base times height. So 1/2 base times height, your base is 4, your height is 3. Sorry about that. And so 1/2 times 12 is 6. Well, we did say the front and the back are the same, so I'm going to go ahead and put a 6 here. Now let's take a look at the right side, okay? The right side. And this mimeopad is acting a little weird, so hopefully it'll continue to work okay. I think my computer's got some problems tonight. Okay, let's take a look at the right side. Here's the right side. That's a rectangle, and it's a rectangle that's a 5 by 2. A 5 by 2, so 5 length times width, 5 times 2, the area is 10. And now using red, I'm going to highlight the left side. Here's the left side right over here. Everybody see that left side? And that is, I don't know, it's a 3 by something. What is that right there? Well, look at this down here. If that's a 2, then this right here also has to be a 2. So I have a 3 by 2, which gives me a 6. So let's go ahead and add these up very quickly. 18, 28, 36, I believe is what you would get. So your answer is 36. Now it's area, so we say square meters. 36 square meters. So you getting this okay? This is how you find the area, or excuse me, the surface area of prisms. The surface area of prisms. Now, let me see what's next here. That's going to be hard for you to draw. Let me go ahead. No, actually, this is in your book. This is in your book. I'm wrong. So if you would now write this in your notes, would you please? Write page 485, number 3, at, that's an at symbol, pretty bad at symbol, at the top. Do you see the number 3 up top there? So go ahead and take a second and write this in your notes, page 485, number 3 at the top. And now we're going to go ahead and find the surface area of this figure. All right. Well, it looks pretty much like the last one. I mean, we're going to have a top in this case and a bottom. I'm going to go ahead and stop right now and highlight those for you. Okay. So let's find the surface area of this object. Well, here's the top. And here's the bottom right here. Okay? And they're going to be identical triangles. They're going to be identical. Okay? So there's the top and the bottom. They're both triangles. Let's go ahead and write that in. So I have a triangle and a triangle. I'm going to go ahead and find the area right now, I think. Now, how do you find the area of a triangle? 1/2 base times height. Now, do you see this triangle right here? I'm going to color it in for you. Everybody see that triangle right there? If I were to write that triangle right here, would it not look like this? You would call this an 8. See this right angle right here? Here's the right angle. Let me go ahead and erase this real quick. See the right angle right here? So I'd have a base of 8 and a 6, or if you turn those around, if you put the 6 down here and the 8 here, it really doesn't matter. But do you see how the height of the triangle and the base of the triangle are going to be 6 and 8? So 1/2 base times height, that's the same thing as 1/2 times 48. 6 times 8, or 8 times 6, so 48. And 1/2 times 48 will give you 24. So the area of the top is 24, and the area of the bottom is 24. Now, I hope I'm not losing you here. It's hard to not be there to see your faces and to kind of read you. However, if you'll look here, what I would have next would be the front. Let me highlight that for you, okay? The front. You can go in any order, okay? You could have done right side first, left side, whatever. Here's the front. Now, if you'll look, students, there's no back to this. This thing comes to an edge in the back. See that edge going up and down right here? My pen's on it right now. There is no back side to this. So when I put a front, I'm not going to put a back, okay? Now, what is that front? I just highlighted it for you. Isn't that a rectangle? Sure it is. And so I want length times width. The length is 10 and the width is 4. So it's going to be 10 times 4. So the area of the front's going to be 40. All right. And now continuing on, I have a top, bottom, and a front. And now let's go ahead and look at the right and left side. And they are not going to be the same. They're going to be different, so please pay attention and watch this carefully. You'll see it when we start looking at the numbers here. Okay, here's the right side right here. I'm going to highlight it for you. And do you see that rectangle has a length of 6 and a width of 4? Sorry, excuse me. It is a rectangle that is a 6 by 4. Which is an area of 24. Now, be careful on the left side. Watch. You can't always assume they're the same. Here's the left side right here. Okay. Now notice I've got this length right here is 8, but I have no idea what this is. Or maybe I do. Look down here. Isn't that a 4 right there? So if that's a 4, this has to be a 4 also. So 8 by 4. We have a rectangle. That's an 8 by 4. So 8 times 4 would equal 32. So let's add all of those areas up. 4 carrier 1, 5, 9, 11, 14, 144. So the answer is going to be 144 square centimeters. Okay? Now y'all have done really, really well. And that's how you find the surface area of prisms. You list out the faces, you find the area of each face, and then you add them up, okay? I do want to give you a chance to earn some bonus points, and right now I know I've not done a very good job of that. So I'm going to go ahead and just stick a problem in here. I hadn't planned on it. Here it is. It's not what I wanted to hit. Let's try this again. For 1 bonus point, I would like you to go ahead and copy this problem into your notes. If you need some help, I want you to put a rectangle like this. There we go. And then put one back here that should be like the other one. And then connect these corners like this. Of course, I have a little cheat tool here. It's helping me, so you don't have that. There. Okay. Let's put some numbers on this solid. We're going to say this is 10. Go back to marker here. We're going to say this is 10 inches. We're going to say this is 12 inches. And this height going up and down right here, right there, we're going to say that's 3 inches. So, you're on your own. let the video run, please. I'm going to sit here for about a minute. And I just want you to find the surface area of this solid on your own. I'll kind of ramble while you're working on it. You got to ask yourself, how many faces? Do I have a right? Do I have a left? Do I have a top? Do I have a bottom? Do I have a front? Do I have a back? All of that stuff. And go ahead and try to work on that, okay? And I'm just going to let the video run. I'm just going to sit here and wait a minute while you work on this. Notes are totally fine. Just don't use other people to help you. Hopefully you have this copied down by now and you're working on it. I'm going to start working on it myself, so don't look up at the screen unless you're forfeiting your bonus points, okay? And remember, I might start off with top and bottom. You might have started off with left and right. That really doesn't matter, okay? That does not matter what order you go in. Now also keep in mind that some of you might have viewed this thing. I'm telling you, different students view figures in different ways. This is kind of funny. Hopefully you're finishing up here. Some of you might have thought this was the top side right here. Right here. Like a big sandbox or something. That's what I did. I looked at that as the top myself. But I can guarantee you some students, maybe not in this room, but some students, now watch this, some students would look at this as the top, like it's a real tall tower, and they would look at this as the bottom. Do you see that? Like it's a real tall tower, like you're a bird up in the air looking down on top of this figure, and that's the top and that's the bottom. So don't be discouraged if you had, maybe your top was 30, but yet your front and back was 120 or something like that. That's really okay as long as you have 120. I'm going to go ahead and start going over the answer now, so you might want to pause the video. If someone's not done, feel free to do that until they're finished. What you need is to have 120 for two of your faces, 30 for two of your faces, and 36 for two of your faces. Now I could have done a better job. I just made this up cold turkey. It probably would have helped if I would have taken my white pen and maybe dotted some of these lines so you would know which ones were supposed to be in the back and which ones weren't. But that's either way. My point is this. I hope you're getting this surface area thing. Now, unfortunately for you, I told you it'd be a very long video. So far this video has been going on for about 22 minutes, okay? It's going to be a long class period. So please, please pay attention, okay? So far, we have been looking at what topic? Surface area. Surface area, okay? Surface area. Now, I want to show you something else that you need to know, okay? Let me go ahead and get my white out here. I don't even know why I have this in here. I don't want this there. Okay, I want to show you something else now that you really need to see, okay? I want you to go back to the problem in which we found this, well, I didn't mean to do that, in which we found the surface area of this object right here. Okay, can you go back in your notes? It should be way back here about 3 or 4 problems ago. Here it is right here, and you should have all this written down, okay? I would like you somewhere in your notes to write this down. So you should have notebook paper, you should be organized. I don't have a lot of room on this screen in front of me here, but I want you somewhere in your notes to write this down, because we've been talking about surface area, excuse me, but we have yet to talk about the lateral surface area. Okay, so I want you to write that down. I want you to write down lateral surface area. Would you please write that down? So far, I've been asking you to find the surface area of an object. Now I want you to find the lateral surface area. And you know what the lateral surface area is? Please write this in your notes. It's so easy. Would you please make note of this? I'm going to go ahead and get a new page up here so I can write it down. Do you know what the lateral surface area is? It's so easy. Please write this down. It's just the, write this down, it's just the surface area minus the bases. So you still find the surface area the exact same way when I ask you to find the lateral surface area, okay? But you just don't include the bases. Now, if that's confusing, then let me show you what I mean. Watch this carefully, okay? Let's go back to this problem here. So somewhere off to the side for the same problem, I want us now to find the lateral surface area, okay? Now, the object is setting this way right here. Do you see that all right? Let me get my eraser out, and let's erase. Well, I didn't want to erase all that, but that's okay. I'm going to erase this right here. Now, I'm going to find the lateral surface area. Now, what I just taught you was the lateral surface area is the surface area, except you subtract out the bases. Now, the bases, don't forget, would be the two faces that the prism could be setting on. Like here's one base, and then even though it's not setting on this face, if you flipped it over, this would also be a base. Do you see that? Okay, I'm going to highlight those in red for you. So this side down here that the object is setting on, and this side right here is the base. Okay, those are the bases, excuse me. So what was the area of this face and this face? Well, it looks like it was 3 and 5, so 15. So if I ask you to find the lateral surface area, you still find the surface area, but you just don't include those two areas right there. So don't include the top side and don't include the bottom side. So the lateral, and what would that be? 15 plus 15 is a total of 30. So you would not include 30. So you see how you have 158? Well, somewhere in your notes, make note of this. The lateral surface area would be 158. That's the total surface area. Minus, let me go back a page, minusing out your bases, the top and the bottom. The top and the bottom added up to 30, 15 and 15. So it would be 158 minus 30. So the lateral surface area would be 128 square, and what was it, inches, I believe? So that's all the lateral surface area is. The lateral surface area is just finding the surface area, but you subtract out, or you do not include, your two bases, your top and your bottom. Let's try another one, okay? In your notes, you should have this problem right here. See if you can find this in your notes. It was page 484, example number 2. Now on this problem here, I hope you'll dig deep and give me your undivided attention. I know that you're getting tired and this, but we're almost done, okay? Just hang in there. I told you it'd be a long lesson today, but there's not going to be any homework tonight. Now, watch this carefully. We'll do all of our homework tomorrow, okay? Please watch this, students. You're thinking, oh, Mr. Arrowhead, I see it. Here's your bottom side, and so there is no top side, so we subtract this out. Now, be careful. Be careful. Remember, when we say the base of a prism, remember a prism has to have two faces that are congruent, okay, students? That are congruent and parallel. So technically, we would need to flip, and I wish I could do that with this mimeopad, but you cannot do that. But basically, I need to flip this thing around so that it's setting on this side here. Now you say, Mr. Earhart, why would you want to do that? Because you always want your prism to be sitting on the face that is congruent and parallel to the other face. And so the only parallel and congruent faces I see would be this triangle right here and this triangle right here. Okay? And so when I say to find the lateral surface area of this figure right here, the lateral surface area, once again, it's going to be the entire surface area except you subtract out the what? Well, let's go back here and look. You subtract out the bases, the two bases, okay? And so looking at this problem here, you say, well, Mr. Earhart, the base, I'm going to highlight it in green. The base is this right here. It's this bottom thing. Well, I know it looks like that's the base, and I know we called that the bottom side earlier, but to be honest with you, when we're talking about bases of a prism, it has to be the two sides that are parallel to each other and congruent. And that would be these two triangles right here. So we're going to subtract out the two triangles. Okay, the areas of these two triangles are 6 and 6. So the total is 12. So somewhere in your notes, make note, if I asked you to find the lateral surface area, the total surface area is 36. Subtract out these two sides here, 6 and 6, which is 12, and you're going to be left with 24 square meters. 24 square meters. And we call that the lateral surface area. Boy, I hope I've got at least one or two of you still awake. I told you it's going to be a long class period. Let's take a look at this one right here, please. Give me your undivided attention, okay? You did this one in your notes also, okay? Now, please watch this. Now look, students, if I asked you to find the lateral surface area, right now, please don't assume that this is your base right here. That is, I know it's setting on that. I see, well, actually it's not. Let me go back. Hold on one second. There we go. All right. Because of the dotted lines, we can see those dotted lines are in the back. If you'll look carefully, this prism is set up correctly because there's your top side right there. And look at the bottom side. They're parallel and they're congruent. We have two triangles that are parallel and congruent. So those are the two bases that you would want to subtract out if I asked you to find the lateral surface area. So do you see what I'm saying? Sometimes I will ask you to find the surface area. When I ask you to find the surface area, you're finding the area of all of the faces. Sometimes I will ask you to find the lateral surface area, and the lateral surface area is the total surface area except you do not include the bases, the two bases. So here's my two bases. It's my two triangles. Notice they have areas of 24 and 24. Do you see that? 24 and 24. So to find the lateral surface area, I would have to subtract out 48 because 24 plus 24 is 48. And so my answer for the lateral surface area, and somewhere in your notes, make note of this, be organized, and somewhere this problem we did before, make note that the lateral surface area would be 96 centimeters squared. That's the lateral surface area. Okay, so what we've studied so far is finding the surface area of a prism and finding the lateral surface area of a prism. All right? All right, let's continue on and let's see if we can't do some more math. Okay, now let me skip ahead a couple pages here if I can get my mimeopad to work here. All right, let's skip ahead a couple pages here. All right, now I want us to start looking at now finding the surface area of cylinders, okay? The surface area of cylinders. And I would like you very quickly, if you don't mind, please. And I thought I had this in my notes, but maybe I don't. Somehow it became deleted. Oh, here it is. I'll bet you it's right here if I take an eraser. Aha, I was trying to be all tricky. Okay. If you would please turn in your books to page number 485. Would you do that, please? Please turn to page 485 and look at the bottom of the page. They're going to show you how to find the surface area of a cylinder. We're just going to use the formula. Okay, it's a lot easier. But before we do that, I at least want to give you the chance to understand how we've come up with these formulas. Here's a cylinder right here. Now, if you rip the top of it off, right here, the circle, and set it off to the side, there it is, right there. And then if we ripped the bottom of the cylinder off, right here, the circle, and put it over here, there it is, okay? And then if we took this round side, kind of like the label, if you took the label off of a soup can and you laid it flat, it would be a rectangle like this, okay? So when you're finding the surface area of a cylinder, you're really finding the area of what? You're finding the area of how many circles? 2 circles. And you're finding the area of one what? Rectangle, okay? And then, of course, you add those up. Now, we are going to use the formula. I'm not huge on formulas. I like you to understand what you're doing. But to find the surface area of a cylinder, I am going to give you a formula to use, okay? And here is, sorry about the yawn, excuse me. It is late, by 11:40 at night for me. Here are the formulas that you're going to want to use. So would you please copy them? Don't become confused. So far, we have found the surface area and the lateral surface area of prisms. Now we're getting into cylinders, okay? So with that in mind, here are the 2 formulas I would like you to write down. Surface area of a cylinder, we're going to use this formula right here. Surface area equals 2 pi r squared plus 2 pi r h. Now students, look, if you can put 3.14 in for pi, if you can substitute in a radius, substitute in the height, you can find the surface area. These are pretty easy, okay? Now, if I asked you to find the lateral surface area, here's the formula for that. So please write this down, all right? The formula for the lateral surface area would just simply be 2 pi r h. Okay? Now students, that's pretty simple. So let's do a couple of these. I'll give you a chance for some more bonus points, and then I'm done. And maybe, I can't promise, but maybe you'll have a little bit of time to yourself. We'll see. Okay, here we go. Let's go ahead and let's find the surface area. I'm going to go back and cut and paste these formulas real quick. Yeah, I don't think that's going to work. Sorry about that, students. I apologize for wasting your time. All right, here we go. Let's go ahead and find the surface area of the cylinder. Now, before you write this down, this should be in your book. Yes, it is. So instead of writing this cylinder down, I'm trying to save you time today. Just write in your notes, page 486, example number 3. And that's going to save you trying to draw this picture. Okay, first of all, I want you to find the surface area. Now, I just gave you a formula, and the formula should be this: 2 pi r squared plus 2 pi r h. Well, let's make some substitutions. It's so easy. 2 times 3.14. Well, the radius, now here's a circle. Do you see the circle right here? There's the circle right there. I'm trying to highlight it for you. Pretty sloppy, but you get the idea. Well, there's the radius. There's the radius of the circle. It's 3. So the radius is 3. Then don't forget to bring down your exponent. It's squared. And then plus 2 parentheses 3.14 times the radius 3 times the height. Well, here's the height right here. There's the height of the cylinder right there. And we're going to call that 4. Okay? Now, I know a great teacher has all this done. I forgot to do that, and I apologize to you. Okay, I'm very sorry. But try to do it in my head real quick, I guess. I don't know what you would get here. 9, 18, 3.14 times 18. Let's see. 25, 314. I'm getting 56.52, and I hope that's right just for this part right here. Okay, so with your calculators, I would go ahead and square 3, that's 9, and then times 3.14 equals times 2 equals, and I hope this is what you get. Now over here, then put a plus sign, so 56.52. Now over here we're going to have, wow, I don't know what this would be. It would be 151. I think it's going to be approximately 101. I could be off. It might be 100.9 or something, but it's going to be around 101. Okay? No, that's not correct. Give me just 1 second, please. It's going to be around 95. Around 95, okay? But anyways, when you add, so when you take this group right here and do all your multiplication using your calculator, you'll get 95 approximately. Add these together and you should get approximately 151 square inches. Now I'm sorry I didn't have that ready, but nonetheless, there is the surface area. I think most of you can work a calendar pretty well, okay? Now, I want you to find the lateral surface area. Find the lateral surface area, okay? Now, students, would you please watch this? Would you please watch this? Look at the formula. Look in your notes for the formula. Isn't the formula this? 2 pi RH, isn't it? Sure it is. Look right here. Look, we already did 2 pi RH. It's right here. I'm circling it for you. We already did it right here. Do you see that? And we got out 95, approximately, something like that, about 95, 94, 95, around in there. So when I ask you to find the lateral surface area, it's just this part of the formula right here. So we already know it. It's 95 square inches. Now again, I did that in my head. It might be 94 point something, but hopefully you get the idea. So 2 times 3.14 times 3 times 4. So there's the lateral surface area. So let's go back and look at these two formulas real quick. Do you see how the lateral surface area formula is the exact same thing as the second part right here of your surface area formula? Okay? So that might help you a little bit. Okay, let's do one more and we are done. All right, if you want to write this in your notes, this is for bonus points. Page 486, number 5. Page 486, number 5. Now, if you're looking in your book, this is what you're going to see. I'm going to try to get fancy and do something here. I'm going to try to turn this thing because it really doesn't, let's turn it this way. It really doesn't help when it's sideways. That's how I'm going to view this. Okay, if you want to turn your books, feel free to do that. But what they're giving you here is they're saying the entire radius all the way across is 12 and the height is going to be 10. All right, so I'm going to go ahead and cross this off and put my 10 right here so I can read it. I'm going to go ahead and cross this off, and here's my 12 right here. Here's my 12. So the diameter going all the way across is 12. Now, students, here's what I'd like you to do. I'd like you to first of all find the surface area of this cylinder. Now, I want you to do that for one bonus point, okay? So go ahead and start working on this. All that I'm writing right now is very simply just the formula, which you already have in your notes. So for one bonus point, I want you to go ahead and find the surface area of this cylinder. Not the lateral surface area, but the surface area. Okay? I'm just going to pause while you work on this. I am going to start working on it in just a second, so please don't look at the screen while you're doing your work there. I want to say one thing to help you, and if you messed up and you want to change this, you can still have the bonus point. Remember, the diameter is 12 going all the way across the circle. So that means half of 12 is 6. The radius would be 6. So please don't use 12 for the radius. Be sure and use 6, okay? Okay. Pause the video if everybody's not finished yet. That would be fine to do. And if everybody is finished, let's go ahead and go over this. Well, 2 times 3.14 times r squared, and don't forget 6 squared is 36, not 12. 36 times 3.14 times 2 does give you 226.08, okay? And then 2 pi rh, well, 2 times pi times 6 times 10 would give you 376.8, and then simply add these two together, and this is what you'll get out. Now, lateral surface area, we're running out of time, and I know that we got to really cut this short now, so here we go. Lateral surface area, remember what I taught you? It's just this part right here of your formula, that's all that it is. So that equaled that, which equaled that, which is this part right here. So the lateral surface area will just be 376.8, okay? And that's all you would need to know for the lateral surface area. You've been troopers today. I have not been there, but I'm sure you've listened well, and I really appreciate that. Tomorrow I will not give any notes, just homework. You will earn some more bonus points tomorrow for your quiz, so please be ready for that. Turn your homework in if you've not done that. There will be a quiz on Friday. Have a great day today.